Okay, so we were rudely cut off after the 15-minute time limit, but hey, you might have needed a break. At any rate, welcome to part 2 of section 1.5. I was drawing a bar graph, and we had completed the red bar, so the green bar goes up to 3. And again, you want to try and make the widths of these things the same to not mislead anybody that's going to look at it. And then for the blue bar, I'll put that over here, and that should be about the height, about the same width. So as you can tell, I'm not the best artist, but if I was to ask you to draw this by hand, which in this class, since you're online, I won't, this is what you would have, and I would be totally fine with this. Tells me you know all the qualities of a bar graph. You got a title, you got your data values, you got the frequency axes, you got the label down below that tells you what those different bar data values are, and then you got your bars that go up to the frequency height. So you can look at the top of the bar and know that red has 2, green has 3, blue has 1. All right, so with that in mind, what I'd like you to do is pause this video and create a bar graph with the frequency on the vertical axis for this, and also start out with a frequency and relative frequency distribution, and pause. Okay, I'm going to go through this now. So I'll do the frequency, relative frequency distribution first. So given that these were grades, so the grade here, frequency in next column, relative frequency in the next column. And the grades here, we got A, B, C, D, and F. And when you count through those, you should have got a 5 for the A's, 4 for the B's, 7 C's, 3 D's, 1 F. The total for this is 20. And then you got 5 out of 20, which reduces to 1/4. I'm just going to leave it as a fraction. It's totally fine to do that. We'll have 4 out of 20, which is equal to 1/5. You have 7 out of 20, which is equal to 7 out of 20. And 3 out of 20 also doesn't reduce. 1 out of 20 also doesn't reduce. So that's all I need to see for grade, frequency, relative frequency. If you got those numbers, you're doing good. And then the bar graph, I'm going to give it the title, class grades. You know, if you wanted to do it something different, or if you had a different title, that's fine, as long as it was similar, similar in its descriptive nature. And then here we're going to have some bars, and we're going to have the frequency, and I only need to go up to 7. So 1, 2, 3, 4, 5, 6, 7. Do try to make these tick marks evenly spaced. Sometimes when I'm drawing on a computer, it doesn't really put things where my pen is. But again, if you're misleading people with misspaced tick marks, it could lead to people thinking that there's more in a bar than there really is. So you've got your frequency here. Let people know that it is frequency. And then down below, we'll have the A, the B, the C, the D, and the F. And let people know that those letters are representing the grade that somebody got. Bar A is going to go up to 5. So start this out. Bar B is going to go up to 4. Again, trying to keep these bars similar width. Bar C goes up to 7. So come across here. May not be perfect since I'm looking at a screen at an angle, and I can't always count on the stylus to be perfect where I want it, but trying to do my best here. And then D is 3, so coming across here, D is 3. Let me give a little more space for that one. Right there. And then last but not least, and I'll line this up a little better here, the F, 1F, and you're done. Okay, so if you have something that looks like that, probably better. But if you have something that looks like that, then you got everything that you need. Okay, so let's take a look then at histograms, because histograms are similar to bar graphs in the way they look, and the untrained eye might even think they're the same thing. But in this class, you are being given the knowledge to distinguish between them. So bar graphs are usually used with qualitative data, things like the letter grades, colors, because those separate bars make a lot of sense for it. But a related type of graph, the histogram, it's often used with quantitative data. And a lot of times it's mostly used with the continuous data. You could use it also with discrete, but it makes a lot more sense even with continuous data, because when you're looking at a histogram, you're still using rectangles for each subinterval. The height still represents the frequency, but here's the difference when this definition of histogram. There's no gaps in between the rectangles, so all the bars are touching. And when you have all the bars touching, it's one continuous thing all the way across the bottom. And the bars are all just, touching as they move across. It makes it look more like it would represent continuous data that has no breaks in it a lot better. So that's the whole point of histograms with continuous data, is the bars aren't split up, just like the data isn't necessarily split up. All the values are possible in between any two numbers that you may have. So what's a subinterval? Because we talk about this up here, it's the rectangles used for each subinterval, data values in the subinterval. Well, because quantitative data may not have a lot of repeats. For example, if you're measuring heights and you're taking with very accurate measurements, you may have things where it's like 5 foot 0.52222 and 5 foot 0.737, and if you don't have a lot of repeats, it often makes sense to put the numbers together into groups. So maybe it's like everybody from 5'5" to 5'9" is going to be in a certain group. You just lump them all together because, maybe you don't have a lot of repeats there, like we did sometimes with that qualitative data. So these groups are referred to as the subintervals or classes. You may even see it called bins in another class. So why do this? Well, you don't really want a graph with a bunch of bars with frequency equal to 1. It's not going to be very descriptive if you just saw a graph and everything was one height. It's like, yeah, okay, great. But if you start lumping them together, and there is a little bit of an art form to this. Some people, you might have to form your classes or your subintervals multiple times before you really get a graph that kind of is descriptive enough when you look at it and be like, oh yeah, okay, that's good. If you have too few subintervals, you're going to have like 1 or 2 really tall bars and nothing else. If you had 2 subintervals, 2 bars may not be enough to really separate the data into something meaningful and show what you're really seeing in that data. So there is a little bit of art form to this. Problems in here, they're going to give you some clues as to how they want things grouped. So you won't have to think about that too much here. But if you're doing this in real life, there's definitely an art to picking the classes, and it takes a little practice. So an example here, we're going to look at the data set 1, 2, 3, 3, 5, 7, 10, 12, 13. And we're going to form our usual distributions here. The number, there's going to be some number that we're looking at in there. The frequency of those numbers, and then the relative frequency. So for the classes, I'm going to use 1 through 4 for the first class, then 5 through 8 for the second, 9 through 12 for the next, and then 13 through 16 for the last. Notice that all of my classes have the same difference between the low and the high number. This is important. Again, this idea of equal width in the bars that we saw in bar graph kind of carries over to histograms, where you want your classes to be equally spaced, equally widthed. Because again, if you start lumping a whole bunch of numbers, like if we just did 1 to 4, then 5 to 12, then 13 to 16, it will mislead people. And maybe you are thinking, especially if the 1 to 4 is taller, you're like, oh, well, there's a lot more 1 to 4s than the rest, so that that's great. But then the 5 to 8, maybe there's none of the 5 to 8, and if you lump it all together with 5 to 12, you're not going to get that difference. So it's all just part of the idea of not misleading people by having weirdly spaced things and grouping things together in weird ways. So you always want your equal widths in the classes. So the frequencies here, there's 4 numbers that are 1 through 4. There are 2 numbers 5 through 8. There are 2 numbers 9 through 12, and there's 1 number 13 through 16, and that would give us a total of 9. The relative frequency then is going to be 4 ninths, 2 ninths, 2 ninths, and 1 ninth. And then for the histogram, if we just do numbers in a set as the title, these things are going to look so close to bar graphs, you're going to be like, whoa, is he drawing a bar graph? But the only difference is the bars will touch. So down here, we'll have our frequency tick marks again. And in this case, I just need to go up to 4. So 1, 2, 3, 4. And you could use, again, relative frequency, but it's going to be the similar idea. You're just going to have tick marks and 1 ninth, 2 ninths, 4 ninths, equally spaced to ensure that 4 ninths is twice the amount of 2 ninths, and 2 ninths is twice the amount of 1 ninths. So then down here, what you're going to do is you're going to have a bar, and this is going to be the 1 to 4 bar, another equally spaced one, the 5 to 8 bar, another equally spaced one, the 9 to 12 bar, and then another equally spaced one, the 13 to 16 bar. And you'll have some numbers, these are numbers that you're working with. So the first bar goes up to a height of 4. Second bar will just go up to a height of 2. And the second and third, I should say, go up to a height of 2. And then the last one is a height of 1. And that's a histogram. Looks a lot like a bar chart, but now you know the bars are touching, it's a histogram. So the shape of the histogram is based on the number of peaks, and if there's just one peak, where that peak is located. So it looks like, I don't want to get cut off again because of the timer, so I'm going to go ahead and stop here. This section is a longer section, but the last one is a lot shorter, I can promise you that, and the first one is kind of short too overall. But I'm going to go ahead and pause here and pick up with part 3 after come back.